at our Pipes to Patients conference. I do want to really quickly highlight the features on your screen, the resources window with the sponsor resources that are on your right side. So there's downloadable resources. We also have some extra CEs, and we also have a reference on how to grab your CEs from this conference. There is also a Q&A window, so please feel free to use that. We had a lot of great questions on the last session, so please continue to throw those questions at us. We love them. And also the speaker bio on the right gives you some information on our speakers and also contact information. So our next speaker is Terra Kremer. She is the Senior Program Manager of Microbiological Quality and Sterility Assurance at Johnson & Johnson. Terra also serves as the technical lead of the device reprocessing Tiger team, which focuses on the acceleration of innovation for reprocessing medical devices. Terra is an innovative leader in device reprocessing for reusable single-use medical devices and is a recognized expert in device cleanliness. Her presentation title is Water Quality, Your Power to Prevent a Series of Unfortunate Events. How do you identify if your department's water quality is cause for concern? As a sterile processing professional, what are your responsibilities for monitoring water quality in your department? Join Terra as she identifies the tools you can use when identifying and monitoring the water issues that can arise in your department's water system. Terra will also examine the important working relationship between sterile processing departments and facilities management to ensure water quality parameters are met. Please join me in welcoming Terra Kremer.
Thanks, Brett. So go ahead and getting started here. As Brett said, I do work for Johnson & Johnson. Long-winded, who am I? I focus on innovation. So lots of research and development on my side, as well as being the co-chair of Working Group 95 for AMY, which deals for water for reprocessing. So the water in sterile processing and the chemistry of it is very near and dear to my heart. So I hope it is to yours as well. So moving on here with the disclaimer, I must mention that the opinions expressed within this presentation are my own and not of Johnson & Johnson. So in starting with our objectives, really we have three main objectives that we'll be working on today. So first, as Brett said, understanding the importance of water quality and the maintenance within sterile processing. The second is understanding the requirements for water quality for reusable device reprocessing. And the third is really being able to give you the tools as sterile processing professionals to understand if there's a water quality problem and be able to communicate that effectively to all levels of management with the impact to patient safety, because ultimately that's really what we're all concerned with here. So in terms of water quality, it's important to really think about why is it important for reusable medical device reprocessing. So water quality requirements for the processing of medical devices are specified in the manufacturer's IFU. Sorry, that moved ahead quicker than I wanted it to. Well, I'll be quick here. So if the devices are exposed to poor water quality during the processing, basically a series of unfortunate events could occur. So we want to be ready for that. And what are those unfortunate events? So let's start with ineffective cleaning and disinfection. So the chemical integration with the water contaminants can really bind those cleaning agent surfaces and prevent them from dispersing the soils. So you heard about this from Alpha earlier today, where she talked about within a validation setting how the water quality is important to be able to lift off those remaining soils on the devices after clinical use and be able to move them into solutions so that they can be removed from the device itself. Steam purity is really important. So in water quality, it's not just talking about what we do to, excuse me, Brett, I just want to make sure, is slide 7 showing? Okay, good. So going back to steam purity. So the non-condensable gases that are in the liquefied version of water can affect how sterilization happens. So water quality is not just important for the cleaning process, but also for the sterilization process. So you're going to hear Don later on today in his presentation talk about that more in detail. But in water quality, we don't just look at what the water is in the liquid form touching the device, but also what the water quality is as we deliver it through mechanisms like steam that are used in the moist heat sterilization or steam sterilization. So the third one is device malfunction. So we really want to make sure that when the device is used on the patient, that it performs correctly each and every time. And if water is used on a device and it causes that device to corrode because maybe it's salt or other water deposits, the device could actually break during that patient use and that mechanical movement. So we want to make sure that any kind of water exposed to the device is not going to cause the device to malfunction prematurely. Fourth one is toxic effects. So when we think about toxicity, it's not just what might be on the device, but also what could be eluting from the device. So if water used on the device maybe erodes that coating on the device that's intended to protect the device material from the patient, then we could have situations like leaching metals that come out of the device as it's being used on the patient, or even pyrogenic reactions. So something like where we have bacteria harboring in crevices of those devices that maybe are eluting toxic substances that could cause harm to the patient during use. So I'll talk a little bit more about that later. And then the final one is really that idea of patient infection. So salt or organic deposits used in the processing of medical devices can inactivate the ability for the disinfectant or sterilant to really inactivate any microorganisms that are on the device after use. So it's really important that we don't provide a way that bugs can hide and not be able to get sterilized or disinfected as we intended. There's a really excellent study documenting that hard water deposits can affect sterilization. So if you want, reach out and I can send you that publication so that you have it handy if it helps you. So let's talk about responsibility for the device performance. So it's not just the manufacturers that have that responsibility for does the device or equipment perform correctly and the chemicals that maybe interact with that device, but it's also the healthcare facility for sharing that responsibility in that continuation to prevent infection. So, but it's not just the sterile processing department. Let me be clear about this. It's a combination of departments within the healthcare facility. So examples might be infection prevention. We're going to talk a lot about engineering today in terms of water treatments. And then also, sometimes we don't think about finance as a strategic partner for infection prevention, but we really have to make sure that we're thinking about the money that might be required for remediation as we go into these situations and identify where there might be potential problems. So from a holistic perspective, it's really a cross-functional team within that healthcare facility that maintains that responsibility for that device performance over its intended lifetime. And there are a lot of examples that we can talk about of where one facility might get involved, one department might get involved more heavily than others. Infection prevention might come in if there's a bacterial outbreak and really look to understand where the problem is and then put in corrections. to address the concern. But if they don't understand how those corrections might affect other parts of the process, those corrections themselves might be contributing to a new problem that we have to sort of think about. And this is something that I'm going to describe a little bit further on in greater detail as a case study of where this happened. But really, that's why we have to understand holistically what the responsibility is and who has that throughout the healthcare facility. So again, the responsibility is not just sterile processing. So although I'm talking to you today about this, one of the things that we want to talk about is giving you those tools to successfully communicate to that multidisciplinary team that's responsible for water quality and how it affects those devices over the entirety of the lifetime. So just to describe this, we really talk about the end-to-end supply chain for reusable medical devices. And to reiterate, we within the manufacturers think about the supply chain as R&D, plan, source, make, deliver, and then to the customer. But we don't just have to throw it over the fence to the customer. This is where we really have to think about that shared responsibility. And again, this is where sterile processing really becomes that part of the supply chain where it continues. So as I talk about the rest of these slides and the responsibilities within this, I hope you think about yourselves as sterile processing as that critical part of the supply chain that we all have to support with the tools to make sure that you're successful. And water quality is just one of these tools, but it's actually one of the most important tools because water is foundational to the ability to be able to clean and sterilize devices effectively for subsequent patient use. So let's talk about the manufacturer part of the supply chain and how we set it up and deliver it to sterile processing so you do have the right tools. So as I mentioned, manufacturers have a responsibility for water quality when we are manufacturing those medical devices, whether single use or reusable. So within our manufacturing processes, we also have to maintain control of our water systems, and they're designed to deliver that consistent water quality that maintains what we anticipate to be the right quality of water for the process to maintain the microbiological quality, which includes the chemical quality of the product that we're manufacturing. So we do a lot of routine monitoring of both the water system as well as finished product to make sure that the devices that we're delivering, again, whether single use or reusable, are of the right quality when they get to the customer. Then we know for reusable devices where we transfer that responsibility to water quality to the healthcare facility that we have to identify what the right level of water quality is for the process that we've defined. So Alpa earlier went through the validation process and how those specific water quality categories are set up in different parts of the processing steps. We go through that very thoughtfully so that when we define the device lifetime, we are giving you the right understanding to say, if you are using the quality of water that we specify, this is how long the device will last. Or these are indicators for when you can start looking at, does your device need to be changed out or maintained? So how do we communicate that level of water quality to you? So I think Alpa probably told you about manufacturer's IFU, which you are all very familiar with, where we actually specify for different parts of the process what water quality is required. So you might see terms like utility water or critical water as two of the recognized terms from the AAMI standards, AAMI guidance documents TIR 34, that indicate what that water quality level should be and how to make sure that your system is maintaining that. So as I said before, we can't just toss this over the fence. We really need you as Sterile Processing to be those partners for that continued responsibility. And TIR 34 really talks about 4 different responsibilities. But again, thinking about it, it's not just Sterile Processing, it's a multidisciplinary team that really is responsible holistically at the healthcare facility for that water quality. So let's run through them. So the first is the assessment of the water quality to meet the IFU. So this is typically the water maintenance personnel at the healthcare facility that performs this assessment of the quality. And it starts with the tap water that comes from the public utility source that's analyzed usually by an accredited facility or within the test laboratory with specific analytical equipment that has the expertise in water quality to determine what the water quality is, and if so, what is the type of treatment. So then we look at identifying gaps. So the water maintenance personnel, after they go through this assessment early on to see what might be required, they should be in collaboration with the sterile processing personnel or other people that are using water as part of reusable device processing steps, so that they're implementing the right treatment process based on the assessment in step 1, and the water is of the right required quality for any kind of processing steps that are done within the IPU. And then third, medical device reprocessing areas should be audited to make sure that the water that is in contact with the devices is correct within each area. So it's not just the treatment process, but it's also at what stations the water is being used within sterile processing, making sure that that meets the appropriate level that's required by the IFU for the processing step that's done at that station. And then finally, where it's applicable, and there's a lot of caveats to this that will be specified within TIR 34 and the upcoming standard ST 108, monitoring procedures need to be established to ensure that over time, that water quality continues to stay the same, or it continues to maintain the right level of quality that is defined up front. So we don't see drifting over time or with seasons that could possibly impact the device over its lifetime. So this is where we talk about you have the power for preventing a series of unfortunate events. And so the remainder of what we're going to talk about today is really the tools that you might need to exercise this power and always make sure that devices are safe and effective for the subsequent patient use. So we're going to talk about the responsibility for how you identify maybe different issues within the water system. But this is really, no matter what your position is, you have the ability to see something and say something. And with the right amount of knowledge that we have here, you'll be able to determine what the water quality issue might be and maybe how to get the right people involved to fix those things. So we're going to do this through 4 phases. So first, we're going to go into the requirements. So it's really important to understand, okay, what are you looking for? The second is we want to go into identifying the risks to the devices and then how to identify if there are problems. So you really have to understand why it might be impactful. And so that way you can better explain why you have to do what you have to do. The third is we're going to walk the line, because you don't have to be a water quality expert to really understand where you might have problems within your water system. A lot of what we're going to talk about today is just common sense. So if you provide an atmosphere where microorganisms like to grow and proliferate, and you give them food and water, they're going to grow. And so it's very easy for you to see where you might have some problems where if they're not moving out of the system, they might have an opportunity to proliferate and cause a problem. And then fourth, we're going to really give you those tools to fix the problem. So again, you might not be the person that can actively fix the problem, but you're the person that can say something and engage the right people that do have the right expertise or maybe the finances that are going to be needed to give you what you need to fix the problem holistically. Okay, so first, we're going to know about what the problems are. So what are the requirements for the processing of medical devices? We're going to go through that very quickly. How to interpret the monitoring test to maintain water quality, because we want to understand, we're giving you a level, but what does that level mean? What do those numbers mean? But ultimately, we're going to talk about putting things in writing, getting more people involved, and really putting together a foundational program for water system treatment that really gives you that visibility and the power to have the right people involved so that you're making good decisions on it. Okay, so we do have a question that says, so would the engineering department have a schedule and monitor on how the results of the testing and how often they would need to do the testing? That's something we're going to go through in the next slide. So it's a really good question. Okay, so right now in AAMI TIR 34, which is your main tool for the water quality requirements for reusable device processing, there's two categories. There's utility water and there's critical water. So right now, utility water has specific testing requirements that give it that definition for utility water. So we're going to talk a lot about what does it mean? Is it tap water? Is it not tap water? Let me be clear. Utility water has criteria for quality, which means that it could be tap water, meaning that the water you turn on from the tap from the municipal company that you work with, it might be good, depending on your geographical area, or it might not. So this water is typically used for the pre-cleaning, cleaning, and rinsing part of device processing. And I think Alpha went through some of those steps with you earlier today. Critical water, however, is of a higher quality, and it's used in the final rinsing of those cleaning steps. The reason being is the idea is that clean water is really shearing off anything that may have been left as a residual from the poorer water quality that is utility water that's used earlier in the process. So in addition to the rinsing steps that could be in a washer disinfector or manual or in an AER, that water is also used within the thermal disinfection phase within the washer disinfector, where we're heating up that water to a temperature point, and it's facilitating the disinfection of microorganisms as part of that washer disinfector cycle. And in addition to that, we're using it in the terminal sterilization process. And a change here is there's a new AAMI standard that's coming out that's based on TIR 34, but it sort of takes it to the next level, and that's ST 108. So you're going to start hearing a lot about ST 108 and the requirements for ST 108 because they are a little bit different than TIR 34. So within the rest of this presentation, I'm going to talk about TIR 34, but I'm going to kind of give you some clues as to what you have to start looking for in ST 108 so that you're aware that going back to the question that we had earlier, there's a loose sort of schedule and monitoring requirements in TIR 34. It's not very well defined, but it is very well defined in ST 108. And it's defined not only on the performance qualification piece that engineering might do, but it is also very well defined on what would be required by sterile processing personnel in the routine monitoring of that water quality. So it also gives you some clear instructions on what testing to do, what the acceptance criteria is, and then what to do if you're not meeting the acceptance criteria. So where TIR 34 gave a lot of really good general guidance, ST 108 will take it to the next level and really give you that deep dive into tools that you need to make sure and validate that your water is of the appropriate quality for both utility water and critical water, as well as steam. So something to look forward to. Okay, let's talk about tap water. We spent a lot of time in the AMI meetings talking about what tap water and how it's defined. And we understand at Sterile Processing, tap water really just means that. It's water that comes from the tap. So when you turn on the tap, you may not know, does tap water mean it's utility water? Does tap water mean that it's critical water? Or does tap water mean that it's just tap water that came from the municipal facility where they basically follow EPA regulations and it may not be anywhere close to the quality of water we need for device processing? So I'm going to say tap water really depends. It's tap water. So sometimes tap water is going to be of that quality that you might get for utility water, but other times not. It might have things like bacterial endotoxin in it, which we're going to talk a lot about in the next couple of slides. Organic pollutants. So we're talking about microorganisms, plants, molds, yeast, fungi, little animals, and pesticides all can be in that tap water. Dissolved salts. So hard water. We all talk about hard water, what it does to our skin, what it does to our hair. We have to think about that as tap water is coming into our facility and what it might be doing to our devices. And then ionic molecules. So within water treatment facilities, they'll often add molecules like chlorine and iron and copper to really prevent that microbial replication in that municipal water supply. But what that means is those ionic molecules coming into the healthcare facility and being in contact with the medical devices can have really unfortunate effects on those medical devices after processing. So let's talk about some areas of concern. So bacterial endotoxin is one of them. So in case you're not familiar with what bacterial endotoxin is, an endotoxin is a lipopolysaccharide found in the cell wall of gram-negative bacteria. So what that really means is gram-negative bacteria love to live in water. And as we're talking about a water system, gram-negative bacteria will be very prolific within water systems. And so it's an area of concern. But the reason we're so concerned about bacterial endotoxin is because of what they do when they come in contact with humans. So bacterial endotoxin is really interesting because it comes from gram-negative bacteria because it's that cell wall. But it doesn't matter if the bacteria is alive or dead. Actually, what happens is when the bacteria dies, it creates bacterial endotoxin and it elutes these toxins into, whatever system it's in. And those bacterial endotoxins, they are pyrogenic, which means they're fever-causing molecules within the human system. So, but it's not just fever we're worried about. It also can lead to device rejection. So if you're using instruments where you're putting in an implant and bacterial endotoxin elutes into the patient during use, you can have an issue where that implant can actually be rejected by the body. So if you're not controlling your water system, perhaps maybe you want to think about using sterile single-use device implants, because remember, we use sets where those implants, although not clinically used, are still reprocessed in those sets over and over again. So thinking about screws and other types of orthopedic sets that might have pieces that stay in the set, get recycled over and over again. But never come in contact with that patient. They're still going to have that patient safety risk if you're worried about something like a bacterial endotoxin that might deposit on it and not be removed during that processing. This is one of my favorite pictures of water, because even if you can't see that water is dirty, even if it looks crystal clear, there is a lot of stuff going on there. Water is amazing. And remember, it's foundational to life, which means that everything needs it. Microorganisms, plants, animals, but we can have other things in there, such as pesticides. Because remember, as we are often closed systems, things that we put in our water in different parts of the world find their way into areas that we might not expect. So we really have to understand that water is a really complex matrix. And just because you can't see that the water's contaminated with things that you don't expect, it still might be. So when we talk about organic pollutants is through total organic carbon, so often known as TOC. So what happens if we have residual TOC on a device? Well, the water residuals can discolor the device. They can interfere with the effectiveness of things like cleaning agents or disinfectants or sterilants. And more importantly, they actually provide nutrition to microorganisms and will contribute to that microbial growth. So again, if you have something like water and then you give it food, guess what? You're going to have a lot of growth. And so we have to think about TOC as an indicator of how much of that stuff is in water, even when we can't see it. So I mentioned hard water before. So what is hard water? So hard water is the presence of dissolved salts like calcium and magnesium. So salts will deposit as hard mineral layers when the water is heated or evaporated. So if you're using it within a system like a washer disinfector, for instance, here's how hard water might look when it's been deposited. So it's that white, crusty stuff you see on the inside of the washer disinfector that are the salt minerals that are depositing and collecting over time when they're exposed to heat. So if we're seeing this within our washer disinfectors, are we also seeing it on our devices? And the answer is yes. If you see it on your washer disinfector, it's an indicator that it's probably going to be on your devices as well. So the problem with hard water, as I mentioned before in the study that I'm happy to send you, is that that hard water deposit can affect how cleaning agents work, as well as disinfectants, as well as sterilants. So if you have a nice crusty layer of hard water, stuff can be growing underneath that hard water deposit, then maybe you're not seeing the ability of your disinfectant or sterilant to actually inactivate. In addition to that, hard water is not good for washer disinfectors. They really don't like it. So hard water deposits can really foul up the electrical heating elements or the heat exchanger components that are really needed for that heat transfer efficiency, which can mean that your washer disinfector is not cleaning the way it is intended to clean, which is really problematic when you're relying on that for the processing steps prior to terminal sterilization or disinfection. So the other thing we have to talk about is ionic molecules. So we talked about them a little bit before, but why are they a concern? And really, what are they? So an ion is an electrically charged atom or molecule. So ions are really important in water for medical device reprocessing. And the ones that we're most particularly concerned with are chloride, iron, copper, and manganese. So any of these excessive ionic molecules can really start to cause things like pitting. So where the surface characteristic of the device is altered and a rough surface becomes apparent, which means that there's it's more difficult to clean. So if you have soil depositing in those pits that are not intended to be cleaned using the instructions for use, what happens? You have residual soil that's built up on a portion of the device that's now harboring soil, which means it's harboring food, which means microorganisms can grow, which means we can't clean and sterilize, which means we have a patient safety risk. And then we have things like our other metals, that if we have too much of the heavy metal ions like manganese, copper, and iron, we can tarnish the stainless steel devices and leave them with a color enhancement of blue, brown, or iridescent. Not something we like to see in a surgical setting. And then you'll hear a lot about pH. So having an incorrect pH of your water really can affect the performance of the cleaning agent or detergent that you're using, especially if it's an enzymatic detergent, because those enzymatic detergents have enzymes that are designed to work at a certain pH range. And if your water quality does not deliver the right pH range for those cleaning agents, it can inhibit their performance, which means that you're not going to get the cleaning expectation that you thought you were going to get. In addition to that, having a lot of water with an aggressive pH, either too acidic or too alkaline, can also damage the device material and result in that pitting and corrosion that I showed you in the previous picture. So now that we know what can happen and what some problems are, let's talk about the levels for both utility and critical water from the TIR 34 guidance. So again, some of these levels are going to change with ST 108. So you definitely want to be in the know about what's going on so you can adjust accordingly. But it's really important to understand that our hard water is measured by the concentration of calcium sulfide. So it's just a molecule that's an indicator of hard water. The conductivity is in TIR 34 measured by resistivity, but in ST 108, it will be conductivity. But it's just the measure of the water's capability to pass electrical flow, and it will be directly related to those ions in the water that we talked about previously. pH is a measure of the molar concentration of hydrogen atoms in the solution, and it's expressed by that pH scale that I showed earlier. Chloride is another indicator of water hardness, and the concentration of chlorine must be balanced to prevent that bacterial growth, but it's not in a concentration that would result in the device damage. So it's a really important level that it's not too much, but it's just enough. Bacteria is measured by filtering the water and then providing nutrients for the bacteria to grow so that we can count these. And we count these as a colony forming unit, or a CFU. And so when you see the measurement from these, it's basically how many CFU are present in the aliquot that we take during that testing. It gives you an indication of what's left in the water. And again, going back to what we talked about before is bacterial endotoxin. That really measures how much bacterial endotoxin is still in the water using measurement tools like an LAL test. Now, again, this chart is from TIR 34. There will be updates to this within ST 108. And it will tell you how often you have to monitor for these tests and at what point in your water system you have to take those samples for the monitoring. Okay, so that was the bulk of the big stuff. So now we're going to talk about device indicators. So what to look for. So if you see something, what do they say? If you see something, say something. So that's true here too. If you see some of these things as you're processing devices within sterile processing, say something, because you're going to notice some simple things that can really be indicators of a bigger problem that if you let go, can really lead to catastrophic events within the facility as a whole. So thinking about in the manual or pre-cleaning step, if you see this on your faucets, do you think this is a problem? Yeah, it's an indication of hard water. So remember, the utility water has a hardness limit. So even that utility water that may be tap water, if it's not softened to a level that is appropriate, you could start seeing salts that are depositing on instruments as well as fixtures, as well as within your washer disinfector. So even that tap water should be of utility grade so that you're not having these types of problems. Because again, those salts may impact your ability to clean and sterilize the devices. So it certainly is a water quality concern. So let's look at another one. So if you put them in the washer disinfector and your washer disinfector looks like this, beautiful iridescent color, is this a problem? Yep. So this again goes back to what you might have as far as ionic molecules that are remaining in your water. And when you consider the final rinse of the water, that it's supposed to be critical, you shouldn't have these remaining ionic molecules left in because they should have been rinsed out during that process. But if these ionic molecules measured through conductivity have the opportunity to be heated, we know that they can damage and discolor during the process. So we'll see not only this discoloration on our washer disinfector, but also on the devices coming out. So it is of a water quality concern. Okay, how about this one? Have you ever seen this? So this is most commonly observed when devices have a high or a low pH residual following the cleaning and going into steam sterilization. So how about this? White chalky spotting or deposits. Again, this is that hard water that's being built up. What about this? A case that's lost its color. Typically happens when these types of rigid containers are exposed to chlorinated water, or they're heated with water of high or low pH. And what about this one? Looks like a device that has some corrosion, some pitting, rusting, and it can happen when it's exposed to, again, chlorinated water or high or low pH. Also happens when saline is used as part of the point of use treatment. So if you are communicating with your OR staff and they're using saline water as a point of use treatment, please ask them to stop. It is really not good for the instruments at all. So we've talked about some examples. You'll have these slides, of course. This gives you the power to detect when you might have some water quality issues. And these are just a few examples. There's actually more in TIR 34 in an annex that really goes through not only what the problems might be, but also possible ways to address those problems. So you already have the power at your fingertips to really be able to dive in and help address these problems. And this annex is staying in ST 108, so it will continue to be a resource for you to be able to communicate these problems effectively to your interdisciplinary team. So what happens if you notice these problems, right? And your device that was supposed to look like the picture on the right comes out looking like the picture on the left. What can you do about it? You'll see a lot of companies that will say, give us your devices and we will refurbish them to make them look like they are brand new. That can work, but I caution you to be very careful about that and make sure that the manufacturer, so the original manufacturer, the medical device manufacturer, has approved this type of remediation, because that resurfacing or taking off of things like, rusting or pitting or cracks or crevices, it might look beautiful to the naked eye, but when you look at what you've done from a microscopic scale, you've actually removed what has already deposited, and you've left these big holes in the material surface itself that can cause a problem in the continued cleaning and sterilization of those devices over time. So if you make more microscopic areas for soil to get lodged and microorganisms to get lodged, it becomes more and more of a challenge and an increased patient safety risk. There are examples of when you can refurbish instruments, meaning they go in and they scrape out all of the bad and they recoat to give you that new surface that doesn't leave them at risk for pitting. But you do need to be careful when you're doing this, that you're going into it with your eyes wide open, and that the medical device manufacturer intended that you could do this with the devices. So use a reputable company. Okay, and very quickly, we're going to go through the last 2 points. So following the line, what does this mean to be aware of dead lanes? So this is where you're going to call a friend and work with your engineering department to really understand that end-to-end part of the water treatment system. So not only the treatment process, but then what happens if it gets to you? So we're going to follow the line by starting with sterile processing and working our way backwards to the water treatment. So what do we mean by following the line? So you're starting at where the water comes out of your tap, and you're following the piping through the distribution loop to identify where there might be points in the piping or the faucets specifically that can lead to areas where the water is not flowing. If water doesn't flow, it allows an opportunity for bugs to stop, eat, and grow. So this is where we really start to worry about things like a biofilm. Because as we get to the point, we have to make sure that all the points in the line don't have an opportunity for microbial growth. So this isn't just somebody else's responsibility. This is everybody's responsibility to identify if there's points in the process that can stop water from flowing, because that's a point at which we can see microorganisms proliferate. So this is why we do point of use monitoring. And this is something you'll see as a new requirement in ST 108 of you will be then sampling at the point of use, at the faucet that you use the water to process those devices to make sure that the water there is of the right quality. Because just because it comes out of the water treatment facility or the water treatment system within the healthcare facility at an okay quality doesn't mean that as it's following through the piping, it's not getting more and more problematic before it gets to you in sterile processing. Because if water doesn't move, again, it has an opportunity to grow a biofilm. And biofilms are tricky, right? They're amazing, amazing cross colonies of microorganisms that actually work to protect themselves. So they are ridiculously difficult to remove. In sterile processing, we talk about biofilm as being residual soil, right? But in water systems, biofilm means a specific thing. It means a collection of microorganisms in a community that's self-sustaining. And these actually, I could go into depth about biofilms, but they are magical, but they also are really hard to get rid of. And so once you have a biofilm, some of your only recourse is to just take out the pipe and put a new one in, because they are that strong at maintaining their foothold within the piping system. So anywhere you see something like this, there might be a dead leg in your system. See this little end there labeled dead end? That's problematic because it means that there is a stopping point where water is not flowing, where microorganisms can grow, where a biofilm can develop, which means you're getting that increased growth over time. And biofilms are not predictable, meaning you might do your monitoring and today you get a huge amount of microbial detection and tomorrow you'll get nothing because it's based on when they slough and when they sort of move the top layer off so that the bottom layer can move up. And so just like in our communities of how we kind of move in and out of cities, that's the way a biofilm moves. So it's really important that once you identify that there are dead legs within your system, that you work cross-functionally within your multidisciplinary team to address these, because just because your indicator says you're in control doesn't mean that tomorrow you won't be. And then the last part, I just want to give you kind of a quick overview of that water generation system so that you understand what engineering is doing to maintain that water quality. So let's talk about utility water. Starting from the tap water, which is the municipal water, then you can go through coarse filtration and then softening. And usually those steps will give you that right amount of quality, but there might be additional steps you need to put in depending on what your starting water quality level is. So don't be surprised if even with utility water, you have additional steps that go beyond what's here in the slide. And that will be really identified as part of your water qualification system that will be really specified as a requirement in the ST 108 standard that's upcoming. But the critical water has a lot more steps to it. So we go through the same kind of beginning steps as we see from tap water to coarse filtration to water softening of solid utility. But then we go a step further in terms of things like advanced filtration, RODI. You might hear some of those terms, microfiltration. There's a lot more that comes into it. Even things like distillation might be a process that's within your quality system. So you really want to understand what's happening within your treatment steps so that you have a full picture of what might be a problem depending on if you have your water quality from utility water or critical water, and if you're starting to see those elevated levels in your monitoring or just indicators on those devices. And then finally, going back again to TIR 34 and ST 108, there's a lot of resources in there, but it's really important to really understand it end to end. So a nice example of this is if you have we had a case study where there was a Legionella bacteria outbreak. So our friends came in from infection prevention and suggested an increase in chlorine to kill that bacteria and knock it back. But then we saw increased pitting and corrosion of the devices because of those ionic contaminants that didn't get flushed out of the system after they did that step to remediate that bacterial elevation. So these are things you have to really think about holistically within this cross-functional team. If you add more chlorine upstream, what happens downstream? So by going through these steps, you now should have the power and feel empowered to, if you see something, say something and be an advocate for water quality within sterile processing, because you really are the heart and the first line of infection prevention that we see within the reusable medical device reprocessing. So with that, Brett, I think we're ready for questions.
All right, Tara, that was awesome. A lot of great information in there. And I'm starting to see a theme or hear a theme that water quality is really, really important for sterile processing. And I think in general, the entire facility and all of the teams throughout the hospital to understand the importance of it and the role that it plays in patient safety. One of the things I kind of, when I was watching your presentation, is I think in terms of, since I did come from the vendor side, that, we see the IFUs come through, right? And I do think that there is some, there needs to be some accountability on that side as well, understanding the role of water. So, what would you say when you see an IFU that mentions the use of saline or a detergent like an alkaline detergent that can be pretty harmful or destructive to instruments? What would you say to that when those IFUs are mentioning the use of an incorrect practice when it comes to water?
Well, I think we have to be clear of what's an incorrect practice, because
Right.
when I say in general, don't use saline, it's if the manufacturer's IFU doesn't indicate that saline is the appropriate treatment step. So the majority of metal devices, saline is not something we want to use. But there are devices out there that it's part of the practice. So I'm thinking about like optometry. Saline actually is one of the steps that is used during the flushing of those devices and actually is the appropriate eluent to use to do that pre-treatment or point of use treatment that's done before it's transferred. So it's really following the manufacturer's IFU is certainly important, because going back to Alpha's presentation, the manufacturer really develops the right steps that are specific to their devices. So there are devices where saline is appropriate, but you shouldn't default to saline because there are lots of devices where it's not okay. So it should be the exception, not the rule. Now, talking about alkaline detergents, that's one of the things that I think we need to get a little bit more sophisticated here in the US, because what we see globally is alkaline detergents are actually more common in Europe. And there's a good reason behind that. And there's a lot of data that's coming out in the literature that supports that those alkaline cleaning agents are really, really important when you're using something like soils that have been dried on devices, for example, or if you have complex proteins like prions that you're really worried about being able to denature. So most medical device manufacturers, when they do their validations, they do their cleaning validations with those less rigorous cleaning agents. And then they do their end of life studies, which is the repeat cycling over and over again to make sure it maintains functionality and that we don't see that degradation in the device over time. They do that with alkaline cleaning agents. So the idea is actually to be able to give sterile processing the ability to do any cleaning agent within the device. Now, I again go back, this should be, this is an evolution. You're not going to see this in every device because it's a practice that the most progressive companies are trying to use to be able to give you as sterile processing the most options for what you're doing in practice. But I again go back to what's in the IFU, because medical device manufacturers will say if you can or if you can't use some of these things based on the validations that they did up front that Alpha talked about.
Great answer. Yeah, I think there's a lot of truth to that, and especially the more and more research that comes out related to the use of those alkaline detergents, the more that there is use for them, they just have to be used in the right way. Here's one from Lori. So seeing the rainbow metal in washers and on washer racks could be related to the RO membrane. Please give a few more details on what that causes on instruments besides rainbow staining. Could rust type staining or even pitting be from the membrane itself?
Yeah, so I think that's a hard one, because the examples that I gave here in this presentation are not the end-all be-all of if you see this, it's this, right? So if you see something on your devices, you sort of have to put on your investigation hat, and you have to use all the tools at your disposal to really hone in on what the problem actually is. So as the commenter suggested, it's not just the water that could be the problem. You could also be getting some of these introductions through inappropriately maintained treatment processes, such as like the RO process system. So when you're looking at this and you see a problem, engaging that multidisciplinary team and then using those tests that happen maybe at right after the water has been treated, and then down into the distribution loop, and then at the point of use, gives you a lot of information of where your problem might be occurring, because it might not just be the water coming into the system. It might be the system itself contributing to the problem. And so it's not I gave you some suggestions here, we gave you some tools, but at the end of the day, you all are going to have to put on your investigation hat and really dive into using these tools to locate your root cause. Because just because my example gave a root cause doesn't mean it's what you're seeing.
Great. Yeah, great answer. And I think we could probably even do a full conference on just those topics, as far as the intricacies involved and the investigative side of what is actually happening to the instrument. So, Terra, really appreciate it. We're at time and we've got a bunch of questions we didn't get to. So those of you who we did not answer and Terra didn't get to, please be sure that she will make an effort to get those questions answered. We'll filter them to her. And also, if you want to reach out to her individually, her contact info is on the screen there on your right-hand side in the bio. So once again, Terra, thanks so much. A lot of really good information to digest and absorb. And I'm really, really glad that we're starting to hone in on water quality, because it's going to be increasingly more important as we move forward in the industry, and especially with the ST-108 coming soon down the line. Okay, everybody. So once again, thank you for joining us. We will be back here in about 14 minutes. So stick around. We've got a lot of great material to cover and some great discussions to come through with the conference. So thanks again.